cardiac myocytes, and it's called the SA node, or sinoatrial. Sinoatrial node. And it's right on the lateral wall of the right atrium, just below the opening of the superior vena cava. Big vessel that comes down to the right atrium. Okay? Just below that opening, there's this special set of cells called the pacemaker cells, called the SA node. They don't look different than the rest of the muscle cells. The only way you would even know they were there is if you took an ohm meter, which is a type of instrument that can detect electrical resistance, and you were to plot it in there to see where you had very low electrical resistance. That's where you could find it. Well, this is where new heart cycles begin. Okay? That's the job of the SA node, to start a new cardiac cycle. Now from there, the electrical impulses spread out through what are called internodal pathways. Internodal pathways, or sometimes they're just called conducting fibers. Within the wall of the right atrium, the internodal pathways converge on another special blob of cells called the AV node. The AV node, for atrioventricular node. And the AV node is stimulated by the action potentials traveling through the internodal pathways. The AV node takes those action potentials, delays for about 0.1 seconds, so 1/10 of a second, then transmits to bundle of His. It's called the AV bundle, and that's a special set of conducting fibers that come down here through the interventricular septum, called the bundle of His, or interventricular bundle. That's the bundle of His right there. The bundle of His splits into a right and a left bundle branch. Now I've kind of drawn it like it's outside of the septum, but it's really inside that. Just drew it that way so you can see it. Okay, it travels through the septum. So those are left bundle branch and right bundle branch. And what, they travel from the base down to the apex, don't they? Is that how I've drawn it? They travel down here, they get to the apex, and then they turn and they fragment and become these long, thin fibers. These long, thin fibers are called Purkinje fibers. And that's your whole conducting pathway. So we start a new cardiac cycle in the SA node. It spreads through the internodal pathways, sums up in the AV node. AV node transmits after a slight 1/10 of a second delay, transmits to the bundle of His. Bundle of His communicates with the right and left bundle branches, and that transmits to the Purkinje fibers. Now, due to excitation contraction coupling, what that tells us is that first, the atria contract. Okay? We stimulate the atria and they contract. While they are contracting, the action potentials are being delayed at the AV node. So that 1/10 of a second delay is to allow the atria to finish contracting. Then we send the action potentials through the interventricular septum, through the bundle and the branches, down to the apex. They turn and they come back up, the Purkinje fibers, and then they start depolarization from the apex towards the base. And so now the ventricles contract from the bottom up and push the blood out. So something to keep in mind here is that all these things that we've drawn there, the nodes and the fibers, those are all cardiac myocytes. They're all muscle cells. These are not nerves. Okay? They're specialized cardiac muscle cells. They're called conducting cells. So while they are muscle cells, their job is not really to contract. It's really their job to pass action potentials. Okay? Now, you can see different parts of this conducting pathway in some of the different models. The SA and AV nodes, you can only see those on the anatomical part. Mention the part. Now you open up the wall of the right atrium here, and there's this thing that looks like a little bit like a crab or something. It looks like a cave drawing. That's supposed to be the AV node. Okay. Now, none of our models show the conducting fibers. You just have to understand that those go to the wall of the atria. And then you look down in there, and I think you can verify that you can see another little like white cave drawing down in there. Yeah. Okay, that's the AV node. That's the AV node. Okay, so we go SA node, conducting fibers, AV node. Then we travel through this area right here, which would be where the bundle of His is. But it's deep, it's inside there. So we don't have a single model where you're going to be able to see the bundle of His on. Because it's in this tissue. It's between those two areas. It's deep. Okay, so that'd be the bundle of His. And then once we get to here, the right and left bundle branches would travel through there. And those are actually drawn on some of these models. Not all of them, some of them. Not on that one. It is on this one. That's what they're showing you here, this white line. That's indicating the left bundle branch. And over here is the right bundle branch. So right where that is, that's showing you where the end of the bundle of His would be. The bundle of His would go from here down into there. And then we come down, and then ththese little white fibers that are sticking up here would be the what? The Purkinje fibers. Okay. So I wouldn't spend so much time on this minutia, but this kind of stuff is really important for heart function. Okay. We're going to learn about a heart attack in lecture. We'll talk about what happens there. And if you get death of the muscle cells, well, look, if a couple of cardiac myocytes die out here in the wall of the right ventricle, that's not ideal. We don't want that. But that's not really going to kill you. Okay? Because the rest of the heart muscle is going to be okay, and it's going to take up the slack. And it may, long term, you may wind up a rupture there or something, but you're going to be fine with that. But if the cells that make up the bundle of His die, well, that's going to be that's going to impede with what do we call that? Not translation. Well, I'll just call it transmission. There's a medical term they use to call it where the rhythm doesn't translate, where the action potentials don't go from the atria down to the ventricles. If the bundle of His dies, you're going to die. Okay? Because the right and left ventricles are not going to be stimulated. They're not going to contract, and you can't survive that. Okay? So a myocardial infarction somewhere in the conducting pathway can be very, very deadly, depending on where it is. If it just happens somewhere in the internodal fibers, again, that's probably not going to kill you. I've read estimates that about 1 in 5 of people over 65 are walking around with mostly non-functional atria. Anyway, okay. The atria, look, they have to transmit the action potentials down to the ventricles for them to work, but as far as contracting to put the blood down into the ventricles, they don't have a big role to play there. You know, they can just kind of take the day off and the ventricles will still work. But they have to transmit the action potential. So if you have a heart attack that kills the SA node, well, that's going to kill you too. You're not going to start new action potentials. Although we'll talk about some protective mechanisms in there. The bundle of His and the AV node will actually take over if the SA node fails. They'll do so more slowly, so your heart rate will be very, very slow, but they'll keep you alive. Okay. All right, now I'm really going to talk. Okay, so you've got this list here, you've got the book to work through, and essentially what your job is to just go down the list and make sure you can identify everything on that list on the different models. And if you can do that, then you're good to go. Okay. Any questions? So you install a pacemaker if you have some sort of arrhythmia of the heart, where about every 0.8 seconds you should start a new heartbeat. If that's going too rapid or too slowly or erratically, they can actually go, and sometimes they'll actually destroy what's remaining of the SA tissue because it's causing issues. And then they'll put an electrical implant in there, and then this will start your action potentials for you. So you put a pacemaker in when you have some sort of arrhythmia.
But it's placed into the SA.
Yeah, I don't know if they send it down to the other nodes or not. I think it just goes to the SA node. Yeah, or to the wall of the right atrium. The SA node may not be functioning properly. Other times, sometimes you can have a congenital defect where I have a family member that has this issue. Well, not a family member, a friend's family has this issue. They've had several people in the family die of sudden onset atrial fib, and in those cases, there's no warning sign. So few of the people have had prophylactic measures where they've had a pacemaker put in that will take over if it happens. And so there are times they do that. But usually it's just if you have a weak heart and it's having arrhythmias. When you get the heart sound, guys, you'll notice some of them are missing the valves. Okay, I think the newer hearts like this, I think all the valves are in. I don't think any of these are broken yet. But some of the older ones are missing a valve. It doesn't mean it doesn't have one. It just means it's gone. Okay, so find one of the other ones where it's still intact. Okay.
Your exam format,
Mhm.
I know it's 50 questions, but for example, for the tracing of the blood flow, would that be in a question? Would you have
Yeah, so for the-
sitting there and say, that's an example?
Okay, so for the tracing questions, I usually I have pity on you. I make those multiple choice. I used to have to just write it out, but that became way too hard to grade. So I give you a sheet that has like choices A through K on it or something like that with all the different terms in it, and you have to put them in order. So the terms are there, and then all I ask you to do is pick the letter and put them in order. So maybe your answer is going to read A, J, C, B, L, F, and that'll be, if it's a coronary circuit, it might be left coronary artery, anterior interventricular artery, myocardial capillaries, great cardiac vein, coronary sinus, right atrium. That would be a circuit.
So it's like a word thing.
And so specifically for the heart tracing questions, there are multiple right answers. Okay? Because you could go to the left or to the right, and depending on which way you go, the way you get back is going to be different. So all those choices will be there, and you have to pick one
Okay.
and put it in order.
Okay. And in terms of where to listen and so forth, that's material that we'll cover, like for heart rate and so forth.
Yeah, we'll do that probably 2 weeks from, well, a week and a half, the following Monday.
But your questioning on that is what? A model, a question, or how do
well,
you
you'll
phrase it?
actually have to take a blood pressure in class.
No. Okay.
You'll take pulse. You'll have to classify it based on whether it's tachycardic or normal, or the blood pressure is pre-hypertensive or hypertensive or normal. And then as far as like where to listen to the heart sounds, I just take one of these dummies and I put stickers on the chest, and
Okay.
it'll be like which one of those stickers is where you listen to the aortic semi-aortic valve, something like that.
Okay. Okay. Makes sense. Thanks for that.